In this video, we are going to look at the GCSE required practical on IV characteristics. So we're going to use this equipment to draw current versus potential difference graphs for 3 different components, although I've only actually shown 2 here. So have a little think about how you can use this equipment to get a graph of current versus potential difference. The first component we're going to look at is a resistor. Now this is 100 ohms, you might be able to see. Probably best not to use 100 ohms, it's probably best to use one that's a bit smaller, maybe 20, 30, 40, but it will work with this. So the circuit that we're going to build is nice and simple. We've got a variable power supply so we can change the potential difference, an ammeter and a voltmeter to measure the current and potential difference across the resistor. So let's set this one up. We can get rid of the stuff that we don't need, and we're going to connect this up nice and logically. So we're going to start by connecting the ammeter and the resistor in series. So we're going to make a single loop that connects it all up in series. And at this point, I'm not actually going to connect the full circuit because we don't want to have any heating. We don't want the batteries to heat the circuit up when we're not ready. We then need to measure the potential difference of the resistor. So I'm going to use these yellow wires so you can see nice and clearly how it's being connected. And you can see that I'm going to put the voltmeter in second, and it's going to go across the components. It's pointing across the components, and it's connected in parallel. So now we can turn on the ammeter and voltmeter, and we can make sure that it is all working. So I can now connect my circuit, and you see here that I have 2 negative signs, which means I'm measuring the current in the reverse direction. So what I'm going to do to start with is I'm just going to reverse the direction of my battery pack so that I get positive and positive. Now, if you end up with 1 positive and 1 negative, what you would do is you would just switch around the cables in that one measuring instrument. So you can see here now I've got negative and I've got positive, which is not what we don't want. So I just switch it around so I get 2 positives. So what I can now do is vary the potential difference by literally just taking out the cable and putting it in the next connector in the battery. I can repeat. So I now have 3 volts. I can repeat again for 1.5 volts and write those down in the results table. I then need the negative versions of the current and voltage, so I can reverse the direction of the battery. And again, I can repeat 1.5 volts, 3, 4.5, and 6. So I can draw a nice results table of my data. And you can see I've got the positive and the negative values. And then I can use that to plot a graph of current against potential difference. And you see for a resistor, there's a nice straight line through the origin or a directly proportional relationship. The next component we're going to look at is a bulb. Now we could use the same method, but it's not quite as useful for a bulb, because we ideally need a few more data points to see the shape of the IV graph. So we're going to use a slightly more complicated circuit involving a variable resistor or a rheostat. So this is the circuit diagram we're going to use. So we've got a power supply, we've got a variable resistor here, so this arrow pointing to the resistor means it's variable. It means you can change where it's connected and change the resistance. And then we've got our bulb again with our ammeter and voltmeter to measure the current and potential difference. So it looks complicated, but it's really not, and it's really simple to set up. So again, we're going to do this in a really logical way. We're going to start with the battery pack, and we're going to connect it to the bottom 2 connections of the rheostat. Let's use a shorter wire. So we've now got 1 circuit in series going through the bottom of the rheostat. I'm then going to make a parallel branch that is going to go through my ammeter and my bulb. But there is one slight difference with this branch. I'm going to connect it on the other side to the top connection here, so the red connection. So this now means that when I vary the resistance, I will be varying the potential difference across the bulb, and I can change the potential difference across the bulb. If I connect it to the bottom connection, it never changes, right? Because this is across the whole resistance, whereas the top connection here is connected to the variable bit. I then obviously need to measure the potential difference, so I'm going to get my voltmeter and I'm going to connect it again in parallel, so across the two sides of the bulb. And again, you'll notice if I do this one last. So this is my complete circuit. So now it's really simple. I do exactly the same as I did before. I make sure that I have both positive or both negative. So here I've actually got two negatives, that's fine. So I'm going to record these values in a table. I'm then going to move the resistor a little bit, and I'll get two new values. I'm going to move it again, two new values. I'm going to repeat this maybe 10 times, but I need to get a range of values from the minimum resistance to the maximum resistance. So if you sort of do roughly 10 equal measurements or movements along, then you'll get a good range of data. I then need to get the positive values of current and potential difference. So the easiest way to do that is to take the battery pack out, reverse the battery pack, and repeat. And then again, I write down my values, move this, write down my values, move it, etc. So I can get a lovely results table that looks like this. And you can see I've actually got quite a few data points here. 10 is good. If you get some more, that's even better. It will give you a much better graph. I haven't put the negative values on here, but I've told you exactly how to do that. When you plot the graph, you get a really nice characteristic S shape here. So as we increase the potential difference, the current increases rapidly at first, but then as we keep on increasing the potential difference, the current does not increase as much. And if I kept on doing this, if I plotted the last few values, it would level off a bit more as well. Now there is one final component that you're expected to know what the graph is. You can do this as a practical, it works really nicely, or you could just look at the IV graph and describe it. So that is a diode, or equally you can use a light emitting diode. So for that, I'm going to get a couple of crocodile clips and just replace the bulb with an LED. And I'm going to repeat exactly the same procedure. So I will vary this and record my readings down on a table. Now you'll notice that when I do it this way, this does not go on. So at this point you might think, oh, my circuit's broken. Well, if it just worked for the bulb, it's obviously working. So we need to know what a diode is and what it does. A diode only allows current to flow in one direction. So when the diode is connected one way round, it will block all of the current. So you can see here that the two legs, one is slightly longer, one is slightly shorter. The longer one is the positive side, the shorter one is the negative side, and current will only go positive to negative through a diode. So this way round, it's completely blocked. If I reverse the direction of the diode and connect it the other way round, you will start to see that it will go on. Now, if you were paying close attention, I didn't actually connect it the first time, so it was connected the right way around the first time. But if I reverse the direction now, it won't work. So this is super simple. One direction, you're just going to get a load of zeros. The other direction, you'll get nothing happening, and at some point it goes on, and then it'll be on. So this one, you need to change your method slightly. When it just starts to go on, you need to get more measurements here. You'll probably do like one quite a big movement, and then you might get 5 or 6 in this short space of resistances here, and then maybe 1 or 2 over this side. So the results table will look something like this, and the graph, when you plot it, looks like this. So you have 0 current when the potential difference is negative. you have zero current when the potential difference is small, and then very rapidly it turns on. So if you don't get enough measurements in a short space of potential differences here, your graph will look a bit silly. So you need to get, you can space them out here, lots of measurements here, and then you can space them out a bit here.